Complex fractions do not refer to fractions that are difficult. Rather, they refer to fractions that have more than one division bar. As you can see here, we have 3 of them. I'd like to do this first problem in 2 different ways. The first way is to focus in on this main division bar and simplify the numerator and denominator of the main fraction. To do this, I would want to reduce each of those fractions. For this first fraction, I would want to factor a 2 out of the numerator to leave me with x minus 5 over this 4, and then cancel the 2 and 4, which are factors, and rewrite this as x minus 5 over 2 up in the numerator of this very large fraction. Then I do the same thing for the denominator. I can factor an x out and have x minus 5 left over the 3x, and cancel the x's from numerator to denominator, leaving me with x minus 5 over 3. And after having reduced the main numerator and main denominator, I could then multiply by the reciprocal when I do division, multiply by the reciprocal of that fraction we're dividing by. This would then give us x minus 5 over 2 multiplied by 3 over x minus 5. We could then see that the x minus 5's will cancel on the diagonal there and leave us with a simplified form of 3/2. Now that's a very methodical process. Simplify the numerator, simplify the denominator, then multiply by the reciprocal and cancel. Way number 2 says let's focus in on our 2 mini denominators, I'll call them. And let's find the least common multiple of those 2, which is 12x. And let's multiply through by 12x up in the numerator and 12x in the denominator. Technically, we're multiplying by 12x over 12x, which is equal to 1. And when I do this, I can cancel the 4 and the 12 in the numerator, leaving me with 3. And I would have 3x times the existing 2x minus 10. Then down below, I could cancel the 3x with the 12x, giving me 4, and I would have 4 times the x squared minus 5x. Notice how I got rid of my complex fraction very quickly here. Now what I would need to do is continue factoring. I can see up in the numerator, I can take 2 out of those 2 terms, and if I divide that 2 out, multiply it by the 3, I now have 6x out front times the x minus 5. And down below, I can factor an x out of each of these terms in the denominator. Bring that out with the 4 in front, and we'd have 4x in front times the x minus 5. Then we can cancel these fractions. The x minus 5's disappear, the x's disappear, and the 6 over 4 will also then reduce to 3/2. I'm going to focus on this second method to use most on this page because we clear out those complex fractions really quickly. For number 2, I'm going to pretend that the 2 and the 4 are written as fractions over 1, and I'm going to look at my 4 mini denominators, 1x, 1, and x. The least common multiple there is x, and I want to multiply now by x over x. Now, what most people find helpful is to put an x in all 4 corners so that I've got something to physically cancel with. Notice in the top left I have x times 2, which is 2x. In the top right I can physically cancel those x's, leaving plus 1. In the denominator, nothing cancels here. I would have 4x, and then these x's will cancel, leaving plus 1. And we're done. That's the complete answer there, and it was really quick using this method here. For number 3, I'm going to examine each of these 4 many denominators, m squared, 3m, and 6, and note that their least common multiple is 6m squared. So I want to multiply through by 6m squared over 6m squared, and if you want to write it in all 4 corners, that might be a good idea. Just don't get that 3 problem number mixed in with this. In the top left corner, the m squareds will cancel, and we'll have 6 times 1, which is 6. In the bottom right, the 3 will cancel with the 6, leaving us with 2. So we have 2 times 2, 4 times m squared, so plus 4m squared. In the denominator, one of those m's will cancel out with the m squared, leaving 6m times 1, so 6m. And then we can cancel out the 6's and have minus 5 times m squared, minus 5m squared. Now that actually is the solution. You can try to factor and cancel, and as you'll see, when you factor a 2 out of the numerator, you're left with 3 plus 2m squared. And down in the denominator, you can factor out an m and have 6 minus 5m, but you don't have any cancellation. So you can actually leave your answer in either of those 2 forms, but it was necessary at least to check that that would not factor and cancel.